Hey, algebra kids. Today I'm going to walk you guys through, we're going to talk about the beginning concepts of factoring. Factoring is kind of like dividing. It's the reverse of multiplying polynomials. The first idea that we need to focus on as far as factoring is pulling out the greatest common factor. That's what we mean by GCF. So if you don't remember that from your past learning, gosh, I don't know when you guys did greatest common factor. Probably in sixth grade, maybe earlier. All right. So when we're looking for the greatest common factor in a polynomial, we're looking for kind of two pieces. We're looking for the GCF of all of our coefficients. So our numbers. And then we're also going to look for the GCF of all of our variables. We're going to combine those two things together. And we're going to divide the GCF of coefficients by the number, by each number to determine what the number will end up being. So essentially, well, we're going to do an example, okay? But divide your regular numbers by the greatest common factor to figure out what's going to be left behind, which would be your new coefficients. And then you're also going to subtract the greatest common factor from the variables from your exponents. Now think about it when we were multiplying polynomials. When we multiplied polynomials that had variables, the variables ended up adding more to their exponents, right? So if we're going in reverse and we're kind of doing that division, we're taking away from our exponents. This will determine what our new exponents will be on our new polynomial. All right, so if I were to break this up, the first thing I want to look at is I want to look at the easy part, which is like this first example. I have a 4, a -2, and a 6. So those are my coefficients. Okay, what number goes into all three of those numbers? Now my hope is that you would say 2, right? Okay. Now we're going to look at our variables. So I have x to the third, x to the second, and then I have an x. So all three of those terms all have at least one x in them. So our greatest common factor in our variables is going to be x. I can take an x from x, I can take an x from x squared, and I can pull out an x from x to the third. Now, if that is my greatest common factor, is that 2 and that x, I'm going to pull that out to the front. We're going to determine what's going to be left behind. So when I divide 4 by 2, I get 2. When I am factoring or dividing x to the third by x, I'm taking away one of my x's. That would leave behind x squared. And if that doesn't make sense, think about it this way. Think about your multiplication. When I multiply x times x squared, I would get x to the third, right? So that's what we're saying. We're like reversing that multiplication. I'm going to move on to my next term. -2 divided by 2 would leave me with -1. Do I need to write the 1? No. Do you want to? You might. I'll write it just for this example, just so we remember what we did. X squared divided by x would leave us with just 1x. And then let's look at the last term. 6 divided by 2 would be 3. Now x divided by x would leave us with no x's, so that's just going to be a constant term. And that's what's left behind. So we factored out what each term had in common. They had a 2 in common in the coefficients. They each had an x in common. So we pulled those two things out, and then we're left with the trinomial inside. So another way you could look at this, if we simplified it a little bit more, would be 2x times 2x squared minus x plus 3. There's an easy way to check this, guys. Go back through and multiply it. See if you get your original polynomial. If you do, then you did it right. That's the great part about math, is that it's all about learning how to do it one way and then reversing that, okay? All right, let's do the next one together. Let's look at our coefficients again. I have 15, negative 25, and 55. So I see that I know I have a 5 in common, right? And if I took out a 5, that would leave me with 3 and 5 and 11. And do those have anything more in common? 3 and 11 are both prime numbers, so they're not going to have anything in common unless they had one of their factors, okay? So we're going to pull out a 5 is what that leaves us with. Now when I look at my variables, I have x to the third, x to the second, and x again. So all of those have an x in common, so we're going to factor out that x. From there, let's figure out what we have left behind. 15 divided by 5 is 3. X to the third divided by x would leave us with x squared. Negative 25 divided by 5 would be negative 5. X squared divided by x would leave us with just x. 55 divided by 5 would be 11. X divided by x would leave us with no more x's. And there's my factored form of my polynomial where I took out that greatest common factor. All right, one more together. This is a binomial. However, there's more than one variable. So let's break this down a little bit more. So if we look at our coefficients first, we have 9 and negative 3. So we can factor out for sure 3, right? Then we have f to the 7th and f to the 3rd. Now, if you think about what that means in the expanded multiplication form, f to the 7th means f times f times f times f. Instead of, I'll just write it. F times f times f times f times f times f times f, right? That's f to the 7th. Okay. Now, f to the 3rd is f times f times f. That's f to the 3rd, right? So what do they have in common there, guys? I see a pair of f's here, a pair of f's here, and a pair of f's here. You guys see how I kind of paired them up? So what that means is I have 3 f's that I could factor out. That would leave us with f to the 3rd that I would take to the front. Let's see if I have a better color that's not going to blend with the other ones. Red, let's go. I think it's going to be the same, maybe orange. Okay. Then we have g to the 5th and g to the 6th. Now, if I expand that as well, I have g times g, 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 and g. And then g to the 6th is g, 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 6 times, right? All right, let's look at what they have in common. I see 1, 2, 3, 4, 5 that they have in common. So that means I can actually factor out g to the 5th power. All right. This might be the way you guys want to do the variables for a while until you start to get the patterns, okay? Because this helps me also realize what I'm going to have left over. So when I go to write my new polynomial, 9 divided by 3 is still just 3. Nothing changed there. From this first one, f to the 7th, did I have any f's left over? I had 1, 2, 3, 4. So it's going to be f to the 4th. Did I have any g's left over? I had g to the 5th and we pulled out 5 g's. So we don't have any g's for that one. Now I have a minus still. We did 3 divided by 3, which is just 1. I have f to the 3rd is what was in there. We factored out f to the 3rd, so we don't have any f's. We don't have any coefficient other than 1. Do we have any g's though? We have g to the 6th, and that was this one, and we had 1 g left over, so we're gonna write it as minus g. Now what if that second term, we factored out everything? We factored out the 3, we only got 1. Factored out all our f's, we factored out all our g's. What would happen? Would we just have one term? Would it turn into a monomial? And the answer is no, it would not turn into a monomial. What you would need to do is have a space holder, a 1, because what that would mean, and when we multiply that back through, is that this would need to be multiplied by 1 in order to get our second term, if that makes sense. Hopefully that did. All right, guys. That one was pretty beefy. That was a good one to do. Let's do this next one. So if I have, what color did I do the coefficients? -2, 14, -6. Those all have a -2 in common. Wait a minute. 14 doesn't have a -2 in it, does it? So it does technically, because a negative times a negative could be a positive, right? Now, here's why I'm choosing to factor out a negative. Because when we write in factored form, we want what's left behind when we factor something. We want our A term, our first term in the standard form, to be a positive coefficient. So I want that to be a positive, whatever it is, when I factor out what we have, okay? All right, so I'm gonna factor out a -2, and then I'm gonna factor out, I have m to the 4th, m to the 2nd, and m. So if I write that down, I have m to the 4th, I have m to the 2nd in my second term, and then I have an m, just one m in my third. So what do all three terms have in common? They all have at least one m. Can I factor out more than one m? I can't, because the last term only has one m. Do you guys see that? So what I'm going to factor out as my greatest common factor is -2m. And what we're going to leave behind is -2 divided by -2 is 1. M to the 4th divided by m is going to leave me back with m to the 3rd. 14 divided by -2 is -7. M to the 2nd divided by m will be just one m left over. -6 divided by -2 is a +3. M divided by m is just 1, so we don't have to write any m's. And there is your factored form for that polynomial. All right, hopefully we're kind of getting the hang of it. So if we look at this next one, these are bigger numbers. When I'm looking at my coefficients, I have 36, 63, and 27. That tells me that it's a bigger number that's going to come out of it. I can see that 9 goes into 36 4 times, 9 goes into 63 7 times, and 9 goes into 27 3 times. So I'm going to factor out a 9. Now when I look at my variables, I have h to the 3rd, h to the 2nd, and h. So h, h, h for my first term, h, h for my second term, and then h for my third term. So again, I can factor out one of my h's. Now what does that leave me with? 36 divided by 9 is 4. H to the 3rd becomes an h to the 2nd because we factored out one of them. 63 divided by 9 is 7. H to the 2nd becomes a regular h because we factored one out. -27 divided by 9 is -3, and our h was factored out. So there's our polynomial. All right, guys. Hopefully we're getting the hang of this. Let's do these last two. What's the coefficient for that first term? It's a -1, actually. And then we have a 5 and we have a -6. 2 of those are prime numbers. 1 is a prime number. 5 is a prime number, right? But I can factor out a -1 because we want this first term to be a positive. So that's what I'm going to do. I'm going to factor out a -1. Now, if I look at my variables, I have an x squared and an x, and then I don't have any. So I have x times x for the first one, x for the second one, and nothing for the third one. So are there any variables that you guys can pull out of all three terms? The answer is no for this one. So all we're going to factor out is just a -1, which will change that to a positive x squared, a -5x, and a positive 6. Not very exciting, but that's one that would maybe trick us in the future, right? Good one to talk about. All right, this is our first polynomial with 4 terms. Let's take a look at that one. I have 12, -20, +8, Negative 16 for my numbers. Looking at those numbers, I know that 2 goes into all of them because they're even. What about 4? Does 4 go into all of them? It does. So let's factor out a 4. Now let's look at our variables, t to the 5th, 4th, 3rd, and then no t's. So am I going to be able to pull out any t's from this one? I'm not, because just like this last one, there's no t's in my last term. So I know that they don't have any t's in common because this one doesn't have any. So I'm not going to be able to factor out any variables again for this polynomial. So all we're going to factor out is that 4 then, which leaves us with 3t to the 5th minus 5t to the 4th plus 2t to the 3rd minus 4. All right, guys. So I gave you 7 examples. Hopefully this helps. We are going to continue to work on factoring. This is a big topic in this unit. But this is really the foundation of it all, is looking for what every term has in common in terms of the coefficient and the variable. Good luck on your practice, and reach out if you have questions.